Day 2 of axial tilt. Okay, we're really going to explain why axial tilt is important to the Earth. Okay, we're going to rewatch this video just because I played it from a different spot yesterday. We're just going to rewatch the whole thing and get into the rest of our notes. So,
I write a lot of essays for school, but I
do
also
you?
write sales descriptions for my Etsy shop.
Oh wow, how about that?
The Earth travels around the sun. It takes 1 year for the Earth to go all the way around the sun one time. And because the Earth is tilted, sort of like a spinning top, parts of the Earth get more heat and light from the sun at different times of the year. You see? Spring and summer, fall and winter.
The tilt of the Earth on its axis during its revolution around the sun is why we have seasons. Okay? That's the whole reason why we have spring, summer, fall, and winter. Without the tilt of the Earth's axis, we would have the same weather 24/7, 365 days a year, forever. Okay? So it's a very good thing that we have the tilt of the Earth. Okay, so I don't know. Hey, here's how we determine which seasons are experiencing, like what time of the year, what parts of the Earth are experiencing what season. It all depends on the axial tilt. Okay, let me click on this. So, very, very easy concept here. Very easy concept. We're always thinking of things in terms of north and south hemisphere, okay? We're not considering east and west. So, very easily put, whichever one of the hemispheres is tilted towards the sun, okay, is going to get hotter weather because it's tilted towards the sun. Therefore, what season do you think that is? Summer. Okay, and vice versa. Vice versa. Okay, whichever hemisphere is tilted away from the sun is going to get colder weather, aka winter. Okay, but you also have to think there's 2 other seasons that we haven't talked about. Okay, we'll get to that. We will get to that. Okay, and one thing you need to remember, we're about to talk about, so I'm not going to hit you with that just yet. So we talked about summer and winter. Talked about summer and winter. There's 2 other seasons we forgot. What are they? Fall and spring, right? Hey, spring and fall or autumn, depending on what you call it. I'll accept either one. Okay? Those have something to do with the tilt of the Earth's axis as well. Okay, let's move on to the next slide here. Okay, you have these things, and you need to know this word. They have this thing called an equinox. Okay, there's 2 of them. There's one in the fall, and there's one in the spring. Okay, during the autumn, and in parentheses it says fall on your notes, write that in. And the spring equinox, the thing about the Earth's axis is that it's tilted so that the sun is directly hitting the equator at that point. It's right, all the sun's energy is focused like a magnifying glass onto the Earth's equator. Okay, at that point, you're either in spring or you are in fall, depending on the time of year. And the thing about that, though, is on that specific day, the autumn equinox or the spring equinox, which kind of hard to see from this diagram, but the fall equinox is September 22nd, so we already had it. If you had been paying attention on that day, you would have seen that we had exactly 12 hours of daylight and 12 hours of nighttime. Okay? And then what we'll see in March, on March 20th, is we're going to have another one of those days. We're going to have a day that's 12 hours of daylight, 12 hours of nighttime. Okay? Hey, if y'all are not paying attention now and noticing, we have less amount of daylight throughout the day as we approach winter. If y'all pay attention to that stuff. The sun rises a little bit later in the day, and then it sets a little bit sooner each day. It's going to get to the point where basically by like 5:30 every day, it's going to be night. It's going to be dark. Okay, that just happens as you approach the winter months. Okay, hey, think about this. When I just showed you the globe, okay, in respect to the northern hemisphere, if it's summertime here and the earth, the northern hemisphere is tilted towards the sun, what do you think the southern hemisphere is? It's tilted away from the sun. So, hey, let me ask you that question. If that's the case and the northern hemisphere is experiencing summer, what season do you think it is in the southern hemisphere? It's winter. Hey, think about this. Okay, hey, if that's something y'all didn't know, you should understand that concept, because I'm telling you right now, there have been star questions in the past where they will ask you about the southern hemisphere seasons, even though you don't live there. So you need to understand that seasons are opposite in the northern and southern hemispheres. Okay, what season is it right now, technically?
So is it like nighttime?
Oh, no, it's fall. Hold on. No. Shh. Hey, it is fall right now. So what season do you think it is in the southern hemisphere right now? What's the opposite of fall? Spring. Okay, in the southern hemisphere, all those countries, they are in spring right now. They are beginning to warm up down there. One half of... Hey, are we good here so I can move on? Okay, seasons in the northern hemisphere are opposite of the seasons in the southern hemisphere because of the tilt of the earth on its axis. Okay, now, this is one concept y'all need to become familiar with, or y'all need to understand. Okay, it's this thing called direct and indirect light. Okay, direct light would be like, has anybody ever had a magnifying glass and you focus the sun onto a certain dot and you can burn stuff with it? Okay, burning ants, that was a thing when I was a kid. Burning leaves, things like that. Hey, what you are doing when you do that is you are creating direct sunlight. You are focusing the sun's energy into a specific spot, making it more concentrated. Okay? The thing about that, though, is, in respect to the Earth, areas around the equator are always almost getting that direct sunlight. That's why it's always hot. They're getting more energy in a smaller amount of area. Okay? It's higher concentrate. Okay? It would be like, anybody ever buy the cans of juice mix that it's frozen in the container and it's concentrate? Anybody ever made the mistake of drinking that directly from the thing? That's because it's concentrated. You drink it and you're like, oh God, it's like so like sweet and strong. That's because it's concentrated. You're supposed to mix it with water, right? So basically, hold on. Basically, that's what's going on here. This is that concentrated sunlight. That's that heavy sunlight. Hot, direct, intense sunlight where all that energy is. And as you go further north or south, away from the equator, that light becomes less direct. So what happens is the energy from that light spreads out a little bit more and it's not as concentrated. Okay, so you're talking about using the juice as the example, the concentrated juice thing. That would be like actually putting water in the juice, like the instructions say. It's not as sweet anymore, but it's exactly what the juice is supposed to be. Okay, why is that significant? Why does that mean anything to you? Because if any of y'all ever plan on moving further away from Texas, north or south, or you want to go visit, you know, someplace that's really far north, really far south, you're gonna have to learn to deal with the number of like daylight hours you get. For example, people that live in Alaska, depending on the time of year, they can have entire months. They can have 30 days of all sunlight where the sun never goes down. Okay, and vice versa. They can have 30 days of nighttime. Okay, just depending on the Earth's axis and its tilt. Okay, a lot of areas that are this far north or this far south experience things like that. Okay, that's why, sorry, but people in Alaska have like real emotional problems because like the sun setting and all that, that's part of your rhythm. Okay, that's essential to human life. Like when the sun goes down, your body already knows, hey, time to start getting sleepy. Okay, so people that live in areas like that, they don't get that luxury. The sun could be out for 30 whole days. They have blinds in their house that completely block out the sunlight. It's not like these where the sun still comes in. It's like blackout curtains where like even the edges are covered. So when they need to like turn off the lights and simulate nighttime, they will put down their curtains, shut off all the lights, and that's what they got. Kind of crazy. So we're going to watch this video right here. Okay, what this is a time-lapse video from Fairbanks, Alaska. Okay, and what it's going to show you is that the amount of daylight time in Fairbanks during this particular time on December 28th was only almost 4 hours. They only got 4 hours of sunlight that day. Okay, so, hey, also track the path of the sun. Think about it like this during the summer. The sun will rise and it'll basically shoot over the middle of the sky on us and it'll just go directly over you. Okay? Here, because they're so far north, that doesn't happen. The sun barely comes over the horizon for 4 hours and then it sets again. Pay close attention. It's a really interesting video. Right? So, sunrise was at 10:58 this day. Okay, it's almost lunchtime and the sun's barely coming out, but people are already up and going. Like I said, be sure you follow the path of the sun along the horizon. This is the horizon line right here. Follow the path of the sun. You're not going to see it go all the way up here. Right? Basically, this is the highest peak of the sun throughout the day. This is the highest that the sun's going to get during this day at 12:52. So, you know, you're talking barely 2 hours after the sun came up. It's already at its highest point in the sky. Okay, now the only thing the sun can do here is start to go down. And notice, this is how high it gets. It's not very bright out there. That's daytime for them on December 28th every year. Raise your hand. Okay, if you're following it, the sun's already going down. And there it is. So the sun rose at basically 11 and is now already setting at almost 3 p.m. this day. Okay, that's sad. I could not live in that place. I'm sorry.
I mean, technically, yeah, we can sleep in here.
Nah, that'd be fun.
I mean, that wouldn't be fun. Like, you go to school, the sun's not out, and then you get out of school and the sun's not out again. That would confuse you. Like, you're.
It's like it's always nighttime.
Well, I mean, yeah, it would almost feel like that. Okay. Yeah, I know that's your phone. Okay, hey, that's a crazy concept. Okay, but again, you will not catch me living there. Okay, hey, let's check out these two questions here. Now, hey, let's look at this question here, and you can answer on your screen. Okay, the beginning of autumn in North America is in September, but the beginning of autumn in South America is in March. The diagram shows positions of Earth, Moon, and Sun on one day in September and one day in March. Why does autumn start in different months of the year in North America and South America? Hey, respond on your screen right now, A, B, C, or D. Do not yell out loud, please. Okay, why does autumn start in different months of the year? In different months of the year in North America and South America. A, B, C, or D. I'm going to give y'all 15 more seconds and I'm going to lock this up. 10 seconds. Okay. Well, this is another reason why I need y'all to be bringing y'all's Chromebooks. It's a lot easier to do this. 5 seconds.
Bro, it's just not long.
Okay. Hey, I'm going to leave it open, but we got to keep going with this. 11 of you put D, so let's check out D. Y'all put the Earth's axis has a 23.5 degree tilt. Okay, D is the correct answer. Okay. Hey, what D is saying is basically that because of the Earth's axis tilt is the reason why seasons are opposite in the northern and southern hemisphere. That's correct. That's the exact reason why. Okay, Earth's orbit around the sun is not a perfect circle. That has nothing to do with it. North America has a larger landmass than South America. Okay, that has nothing to do with anything. The moon has a greater pull on South America than North America. Again, what you're going to learn about the moon's gravity is the only thing that it messes with is water. Okay, so that has nothing to do with this. D was the answer. Okay, last question. I need y'all to respond on this. Students in a science class in Marfa, Texas, which is a real place, made a poster with a diagram to represent a seasonal change in the northern hemisphere. Which statement best describes conditions for Earth at position 1 in the diagram? So, listen to me here, because this is a pretty difficult question. What this question is telling you, if you're following me up on the screen, is that from position 1 to this position, the Earth is experiencing winter. Okay? What comes after winter? Anybody know? Spring. So from this position to this position, it's going to be spring. From this position to this position is going to be fall. From this position to this position, or sorry, I skipped one. I skipped summer. Summer and then fall. Don't start standing up. Okay, anybody have an answer for this? And we got to go. Okay, bye.